Okay, grade 10s, we've introduced simultaneous equations, simultaneous. So at the same time, we'll be solving for two variables for x and y. Okay, so on the board on the screen there, you have a question. You remember each of these are functions, right? So the one that you have above here, number one, that's a function. The one that you have here, number two, that's a function. So before we get into the math, let's just maybe talk about exactly what you are doing when you're solving simultaneous equations. So let's take a look at this first equation quickly. And it's a linear function, right? A linear equation, meaning x has a exponent of 1. So I'm just going to manipulate it because we know a linear function, a straight line graph. We know that general equation looks like this. Y equals mx plus c. So this equation number one, we want to put it into the form y equals mx plus c. So this positive 3, we'll say that it goes over, right? We understand that we're subtracting 3x on both sides. So it will be in the form y equals. So once that 3x goes over to the other side, it becomes a minus 3x. So it's minus 3x. And there was a positive 2. It's still a positive 2. So that first function over there, the one right on top, if we manipulate it, it looks like that. Y equals minus 3x plus 2. The second one, so let's take the second one over here, and we're going to manipulate that one also to look in the form y equals mx plus c. Okay, so this negative y over here, let's take that over to the other side. Okay, so that is going to become a positive y on your right hand side. So the right hand side you have a positive y. On the left hand side we have that 6x. And let's bring this 25 positive over to our left hand side. So that's going to become minus 25. Okay, let's just rewrite this. We generally like our subject on our left hand side. So y is the subject of the formula. That means y, we want it in terms of y equals. So this is y equals 6x minus 25. Okay, that is 525. So we have these two equations, right? We have this one and this one. So all that I've done so far, now remember when we solve this, we're not gonna necessarily do everything that I've done. We're just doing this part so that we can understand exactly what's happening. So we have these two equations, and I'm going to draw them on a Cartesian plane for us. Okay, so let's get a Cartesian plane quickly. So there's a Cartesian plane. Okay, let's maybe just try that again. All right, here's a Cartesian plane for us. Okay, so if we look at these two equations that we have, this first one over here, there we have a negative 3 as our m value. That just means our gradient is negative, so the graph is going to go down. If we look left to right, it's going to go down, and it goes as at the positive 2c value. So that will look something like this. Don't worry too much about the functions. I just want us to get a brief overview of what we're actually doing, right? If I look at the second equation that we have over here, there's a positive m value and there's a minus 25. So that one probably looks something like this. Okay, so we have these two lines, the one function, which is our first one, this one over here, and then let's maybe put the other one in another color. Let's go with orange. Okay, so the second one over here is maybe represented by that line. Okay, so the picture is you have these two functions. So both of your equations that were given to you in the question, both of them are functions, and they maybe look like that. Right. So when we are solving simultaneous equations, what you are actually doing is you are trying to find this coordinate right here. Right? You want to know, where do your two graphs meet? What is this x value and what is the corresponding y value where your two graphs meet? Okay, so I'll make another video after this where we actually do the math and we show how we find those two values. But for now, what I want you to see when you look at that picture is you can see that at that point, this green dot over here, at that point, the x value of both graphs, the x value of the orange one, the x value of the yellow one, they have the same x value. Okay, similarly, the y value of the orange, the y value of the yellow, at that point, at this green dot where they meet, they have the same y value. All right, now let's get into the actual algebra behind the calculation.